Hello! Have you ever wondered how to know that count is about to give birth? My name is Andres Guerra, and together with my partner Uber Andres Quiroz, we will be talking about in this video about the research article titled "A Markov chain model for a determinate the optimal time to move pregnant counts to individual calving appends we belong an industrial engineering of the program the Santander University.
So Neil Pio is available with Miyazaki University as research in the Faculty of Engineering with 9 article publication. Python with a bachelor degree in mathematics is linking to Miyazaki University as a researcher in the engineering faculty with more than 15 publications. The design professor and the Faculty of Engineering and the University of Miyazaki, Japan, has agreed in electrical engineering and is currently the president of the CTC of Women in Engineering Committee. This article was published in the magazine Sensors, which is classified in the Q1 quartile in the sign, but it was taken from the data-based Sign Direct. This paper proposed a simple random wild-type Markov chain model for predicting the optimal time for moving preparatory codes to individual calving pens. The binding parts of the paper are structured as follows: section of properties and overview of related for words in the file. The proposed system consists of two subsystems: computing the original time for the moving pregnant code to calving pens and predicting the calving time for goods in the pen. This study involved an experimental setup, data collection, the extraction of material behavior, the formulation of the Markov model, and the decision-making process as shown in figure.
For the development of substance number 1, first the author developed an experimental model by the installing a video cybersync system to collect the activities and the behaviors of the pregnant counts and the movement of the area. Secondly, we need the observed day with complete the information on 6 fundamental behaviors, and which is the feeling bound, moving, resting, lying down, routine life, and routine life with standing. Thirdly, the process to formulate the sequence states. For this, they use the formulation the Malaf habits present in the screen and the figure number 1 and 2. The number 3 represent the sequences of the states. Afterwards, the author proposed two fundamental matrices of the article: the relation matrix and the Markov transition matrix, which are the display on the screen behind the matrix C and P respectively. Lines on the two the figure correlation of the occurrence associated with age of the states. Likewise, the present figure shows the probability of occurrence associated with of the states. As a fifth step, the authors carried out the process for the prediction the time of the transfers to calving pen. The prediction of the moment of the calving was carried out using the Markov chain model. They developed the improved election for this calving event and increase as the absorbing state of the Markov chain model. Finally, the authors proposed the fundamental solution and the matrix based on the transition probability matrix of the argument Markov chain model.
In this session, at a short Markov chain model, we will be utilized approximately the optimal calving time. So to complete this, firstly, the data using video sequences captured from the moment a code enters the calving pen in prepare. As only in subsystem 1, this type of cattle activities will be considered. However, a different criterion will be used to label the dominant activity. Within northwest crossing, the mean plus 2 standard deviation instead of just the mean plus on one star. The base from the time concurrency matrix, the corresponding matrix Q is deduced, which represents transition probabilities between different calculated activities. The matrix is a fundamental component for this analysis. The deriving matrix I and Q, which is the identify matrix, and when time is inverse, the optimal calving time can be determined.
The move to the calving pen is aided as an absorbing state in the transition probability matrix P. Then an argument transition matrix P0 in the equation for this figure.
In this experiment, the predicted calving time from the starting point is 2011.67 hours, considering that the time required for moving the cattle to the calving pen is 192.57. In the process system can estimate that the code will come with 19.1 after them moved. In conclusion, the Markov chain model is stipulated in this article, where the fundamental basis for determining the optimal time of transport of the preparing tooth code to calving pen and the optimal calving time of the animal.
The references used by the authors in this article are shown on the screen. We hope that is the being of help to the management to resolve the question both and the begin on the video. See you next time. Bye bye.